Hey, welcome to 5.1, Trigonometric Identities. So, there's a lot of rules I'm going to be throwing at you. Some of them you'll be responsible for knowing, some you will be given for assessments. Ask me in class which ones they are. Here are the reciprocal identities as the first ones. These should be straightforward. Why? Because you know which trig functions by now, hopefully, are reciprocals of one another. Okay, hopefully. Okay. So here's your first six. Pretty straightforward. Next, ratio identities. They could also be called your quotient identities, depending on who you ask. But tangent theta is equal to sine over cosine, and cotangent theta is equal to cosine over sine. Remember when you're doing anything with the unit circle or any lot of different things last chapter, tangent was y over x, right? And what do we associate with sine? Y, cosine x. And then cotangent, of course, is that flipped. Here we are, Pythagorean identities. Just so you don't think I'm completely making these up, I'm just going to do the first one. Sine squared theta plus cosine squared theta equals 1. I'm going to read off the other ones just so you can copy them down correctly. Tangent squared theta plus 1 equals secant squared theta. Cotangent squared theta plus 1 equals cosecant squared theta. So, as you know, when you had your unit circle, that was always 1, right? And we were able to solve all the values, or I just showed you at least some of them, so you didn't think I was making the unit circle up either. You're able to make triangles out of each and every point, x value and y value, and they form a right angle if you bring the point straight down, right? And as you are aware, x squared plus y squared equals r squared, right? So, and we always say cosines x sines y. So if I did this value squared times, or plus this value squared equals this value squared, you would get what? Cosine squared plus sine squared equals 1. Okay, so did not completely make these values up. That's where they came from. But those are your Pythagorean identities. First, it's secant x is equal to 5 over 8. Find cosine x. So, as you're aware, cosine is the reciprocal of secant. So just flip it. Right? So cosine is equal to 1 over secant x. And secant x is equal to 5 over 3, which will get you 3 over 5. There's your answer. Next, I'm giving you cosecant and secant. Find tangent. Now, there's multiple ways to do this. Okay? What I'm going to use, just because we just went over Pythagorean identities, I'm going to use our Pythagorean identities. You know what? Maybe not. I could, but I'm going to just go with it here. So cosine x is equal to the reciprocal secant, so I get 24 over 5, 25 rather. And then sine x I know will be equal to 7 over 25. Now, what do we know about tangent? Tangent sine over cosine, right? So it'll be 7 over 25 divided by 24 over 25. 25's cancel. I'm left with 7 over 24. Now, I want to find cotangent x and secant x, and I'm given sine x is equal to 1 over 6, and the fact that cosine x is greater than 0. So cosine x is positive. I know I'm going to need cosine in order to solve these two, right? And if you look at your Pythagorean identities, there's really nothing that's given that I can do right away, other than the fact that I can find what I said I was going to find, and it's cosine. So sine's 1 over 6, and cosine squared theta equals 1. You get 1 over 36 plus cosine squared theta equals 1. Subtract that 1 over 36, get you cosine squared theta equals 35 over 36, because I subtract that 1 over 36, and you square root it, and you'll get cosine, nope, not squared anymore, because I square rooted it, is equal to root 35 over 36. Now, I know the reciprocal of this is going to get me secant, right? So secant x is equal to 36 over root 35, and then simplifies to 36 root 35 over 35. So there we have secant. Now cotangent as is cosine over sine. We just went over that, right? So cotangent x is equal to root 35 over 36 divided by 1 over 6. Now, if I get a common denominator, that'll get me 6 over 36 instead. So I'll replace it with that. And the 36 is canceled. I'm sorry, I didn't mean to scroll. Giving me root 35 over. Oh, I just realized a mistake because I did not square root the 36. So sorry about that. 6. Go away. 3. So it's actually 6 root 35 over 35. And then this is actually a 6. So I never had to do that. Go away. So 6. 6 is canceled, so that leaves me with the answer of root 35. Once again, I did that because I needed to square root this whole thing, not just numerator. So your next set of identities that you need to know are the cofunction and odd and even identities. I'm going to show you also why I did not make these up. So let's focus just on the top left cofunction identity up here with the sine theta equal to cosine pi over 2 minus theta. So no matter where I'm at on your unit circle. So let's say I drew a unit circle, just a makeshift one. And you start at pi over 2. Now you know cosine 0 right there. So let's say theta is equal to pi, right? So it would be pi over 2 minus theta, right? So minus pi, which gets you negative pi over 2, which is down here. And cosine of negative pi over 2 is what? 0. And sine of pi, which is what I said theta equal to, sine of pi is over here. And what's that equal to? That's equal to 0 as well. Okay? Because no matter if you are pi over 2 apart, which is what you are here, no matter where you're pi over 2 apart, your x and value for one is going to be equal to the y value of the other, and vice versa, which is why these rules are what they are. Okay? So no matter what, these rules hold true. Odd and even. So I'm going to draw another thing right here. So odd and even identities. So if I flip the theta of whatever's in the inside, okay? So let me just read off the rules. So if it's sine, if you're flipping the sign of the, or flipping it from positive to negative inside theta, your sine, cosecant, tangent, and cotangent will also flip as well. But secant and cosine will stay the same. Now, why? Let's say theta is up here, okay? And you're doing negative theta, so negative would be moving in clockwise direction, right? Right down there. Okay, you're down there. So what changed? Your y value is the opposite, right? Yes, so that's why your sine and cosecant flipped. But what happened to your x? Your x is still the same, okay? So therefore, even if you make this positive from a negative to a positive or positive to a negative, you're still going to get the same output for cosine and secant. All right, so we have multiple rules going on here, right? So if sine x is equal to negative 0.37, find cosine of x minus pi over 2. Now, make clear, we'll start with cosine of x minus pi over 2. Now, look at your rule. It's pi over 2 minus theta, or x, or whatever your input is. So I need to flip that, okay, in order to use my rule. So I'm going to flip the sign, be negative of pi over 2 minus x. Now, as your rule states about cosine of a negative value, if your theta is negative, it's going to stay the same. So really, it's not going to change when we flip it. So it'd be cosine of pi over 2 minus x. Now, what's cosine of pi over 2 minus x, or your input, equal to? If you look at your cofunction identities, that's equal to sine theta, to whatever sine x is equal to. And what do you know sine x is equal to? Negative 0.37. Now, will it always end up equaling the same value? No, but you have to go through the rules to make sure that it does. There are going to be examples where it won't, so be careful. Next, we got down here, simplify secant x minus tan x times sine x. Now, a method for simplifying trig functions that sometimes helps is if you put everything in terms of sine and cosine. You know that secant's for equal cosine, tangent is equal to sine x over cosine x times sine x. Sine times sine is sine squared x. And now we got a common denominator. Look at that. Subtract. Giving us 1 minus sine squared x over cosine x. Now, anytime we're simplifying trig values and you see a squared, I want you to automatically think about your Pythagorean identities. That's going to help you out so much. And you probably recognize sine squared. Now, there's multiple ways to simplify this one. I know this sine squared x plus cosine squared x is equal to 1, right? If I move the sine squared x, you know that cosine squared x is equal to 1 minus sine squared x. So I can make 1 minus sine squared x equal to cosine squared x. Cancel out one of the cosines, and your answer is cosine x. That's the simplified version of that trig value. The more we do these, the better you'll get at them. It's just going to take a little bit of practice. Next, simplify. So we notice that we have a cofunction identity right off the bat. What do we know? What's cosecant pi over 2 minus x equal to? Well, hopefully you know it is equal to secant. We've got negative secant x minus tan squared x times sine, or excuse me, secant x. Now, if you look, I see tangent squared x, right? And right away I'm thinking about our identities, right? So what do we know about tangent squared x? We know that 1 plus tangent squared x is equal to secant squared x. So what I'm going to do in order to get to 1 plus, now you can either A, substitute in right here secant squared x minus 1 right there and work from there. Or what I'm going to do, I'm going to factor. I'm going to factor out a secant x, a negative secant x, because that's going to give me 1 plus tan x, tan squared x. And what do we say is equal to 1 plus tan squared x? We're going to get secant squared x. We're going to get you negative secant cubed x. Okay? So that's that problem simplified. All right. 2 more and we're done. So get problems like these two right here, we need a common denominator. Usually a common denominator will get us to where we want to be. So I notice this right part does not have a 1 plus sine x, so you need to multiply that to both the numerator and denominator. Okay? And this one doesn't have cosine x. It's going to multiply by cosine x over cosine x. Give me cosine squared x over 1 plus sine x over cosine x plus, FOIL the numerator, 1 plus 2 sine x plus sine squared x over 1 plus sine x times cosine x. Now, you common denominator, we can add. What are some things you may notice? Well, I notice right away, once again, what did I tell you about the squareds? Look for your Pythagorean identities. Sine squared x plus cosine squared x is equal to 1. So I'm going to get on my numerator 1 plus 1 plus 2 sine x. And then, I don't know why I'm not able to draw here. Is this going to work now? No, it's wrong and clear. Hold on 1 second. Alright, finally got my pen working, so I can write my denominator down. 1 plus 1 is 2. Both terms up top have a 2, so we can factor out a 2 as well. And when we factor out a 2, let's write down what I already have. What do we notice? 1 plus sine x, I factor out a 2. And the sine, 1 plus sine x is canceled, giving me 2 over cosine x. And then 2 over cosine x. As we know, reciprocal cosine, we need to simplify it all the way, so it'll be 2 secant x is your answer for the first one. Now let's do the other one, and then we'll call it quits. Once again, common denominator. So I'm going to multiply the top and the bottom over here by 1 plus secant x. And over here, 1 minus secant x. Which is going to get you a denominator. If you FOIL the denominator, it's going to get the same thing. I'm going to do that. I'm going to use a different color just so I can decipher between the two, and you can as well. Let's use black. So it's going to give me CFC, 1 minus SEC, over, if you FOIL, you're going to get 1 minus secant squared x, plus cosecant x times 1 plus SEC, over 1 minus SEC squared x. You see the squareds. What did I say about whenever you see something squared, what you should be thinking about? You should be thinking about your Pythagorean identities. And you should know that, on second thought, that's going to make me have tangent squared x. I don't know if I want that yet. So if I distribute the secant x's to both terms, that actually is going to help me a lot more. Because that's going to get me and combine what we have. So it'll be secant x minus secant x times cosecant x plus cosecant x plus secant x cosecant x. So what do we notice? These cancel. That's going to get me 2 cosecant x over 1 minus secant squared x. Because I have 2 of them, so they add straight up. And now I think it is probably the simplest thing. 1 minus secant squared x is equal to negative. Be careful of that negative. tan squared x. As we went over, tan squared x, where your Pythagorean identity is what my point was going to be. 1 plus tan squared x equal to secant squared x. And that sign flips because if you flip tangent, these will flip as well. And then I don't want any of my final answers with anything in the denominator if possible, so it'll be negative 2 cotangent squared x, because that's the reciprocal of tangent, times cosecant x. There's your answer. Appreciate you watching. We'll see you in class.